It's an honor and pleasure to be here to talk about connectivity for the network society and 5G. So now we're back on 5G, but I would like to start with showing a quick movie. This quick movie tries to illustrate the network society and the benefits we see for society coming from the network society. But what is the network society? Well, in Ericsson we have a vision, and that vision we call the network society. And in the network society, people, knowledge, devices and information are networked for the growth of society, life and business. So what does this mean? Well, it means that we think that everything that benefits from being connected will be connected in the future. So we're talking about personal devices, industries, business, society. And of course, all of this will put new, tough requirements on our networks. Yesterday we talked about the connected garbage bin. We talked about trucks without drivers. We talked about fleet management. We talked about healthcare. One can also envision things like remote driving of your car, remote surgery, remote education, and so on. Lots and lots of use cases and services. So is this just a dream? No, I don't think so. I think that this will happen. And for me, the reasoning is very simple. Technology becomes more and more affordable, whereas the value we have in persons, in the time, in people, and in the safety of people is just increasing all of the time. So anything that will make us more efficient, that will prevent us from driving around in cars when we don't need it, and that will safeguard people's safety and health will be worth investing in. So I think those are real driving forces for the network society. And then, of course, the sustainability aspect. Not just that our networks for the future have to be sustainable, but also the impact on society and sustainability of society from ICT technologies, reducing traveling, enabling business, enabling remote operations, and so on. So then it's a question of when. When is this happening? And the way we see it, it has already started, and we see some clear signs. The mobile data traffic by the end of 2012 was 0.9 exabytes, And we estimate that 6 years from that, it will have grown by 14 times to 13 exabytes. Furthermore, in the same 6 years, we will go from 1 to 1 billion smartphones up to 3.3 billion smartphones. And the number of mobile broadband users will increase from 1.5 billion up to 6.5 billion in just these 6 years. And these are clear signs that we are moving into the network society. We are also seeing more and more devices being connected, although there is still a lot of potential to come in the coming years. We also think that we are moving in the network society and towards the network society. We are moving from an operator-driven landscape to more a user-driven landscape. And by this we mean that the new services will not necessarily be driven by the operators, but rather by the connected devices and the new services for the connected devices. And also, new services, rather than being vertically integrated like SMS or voice, will be built on horizontal enablers, utilizing the network functionality. We also think that the limit for new services will actually be the performance of the network. So how good can the networks be? Which latency, which data rates, which traffic density can the network support? That will be the limit of the new services to come. And turning that around then, the functionality in the network, the capabilities of the network is key for driving new services. So the network and its functionality and characteristics is really relevant for the new services to come. So when we talk about the network society, in our view, it's actually built on 4 cornerstones: devices, connecting to a network, cloud, and services. So starting with devices, there we will see a variety of devices. It's not only phones and tablets anymore, it will be sensors, industry robots, cars, whatever. Everything that benefits from being connected will be connected. Of course, for all of those connected devices, there will be a variety of new services. Not only the evolution of mobile broadband, but also other services for society, for public safety, for industries, for enterprise, and so on. The devices and the services will pose requirements on the network that we have to meet with having the relevant functionality in the network. So this means that the networks will have not only have the right connectivity, but also have the right functionality to support those new services and the connected devices. And then we are thinking about things like service awareness, being able to optimize for certain services, distribution of functionality, and so on. And that also touches upon the cloud cornerstone. Cloud, partly because it is the platform where the services will execute, but also because we see cloud technology coming in more and more into our networks and being a foundation for the network functionality and the distribution of the network functionality. And that is what we call the network-enabled cloud. So apart from these 4 cornerstones, we have 3 kind of overarching areas. The first one is management. And then it's not only management of networks, it's management of devices, of data, of users, of businesses perhaps. Of course, when everything is connected and we are running business critical and mission critical services in our networks, security is really key. And last but not least, sustainability. Both sustainability of our own networks, but also the positive impact on sustainability in society from ICT technology. And of course, wireless connectivity is key for the network society. So what are the key challenges that we see? Well, the first one has to do with the massive growth in traffic volumes. So we can envision more than a factor of 1,000 in traffic increase that we have to cope with in the future in the networks. Massive growth in connected devices, not only phones, smartphones, tablets, high-definition video cameras, small sensors, robots, cars, electricity meters, everything that benefits from being connected. And this, of course, poses a lot of new requirements and characteristics that we have to fulfill with the networks. So it can be ultra-high data rates or ultra-short latency, can have really, really good coverage and being able to operate at low power. But also things like reliability will be important or key when we run mission critical and business critical. And requirements on being able to cope with very high density, both device density but also density of traffic. And on top of that, or at the bottom, this also has to be affordable and sustainable. So it should not drive costs to a degree where it cannot be economically feasible to deploy it, and it should be sustainable. So, trying to illustrate some of the scenarios or use cases we see for wireless access in the network society, we have tried to illustrate in this picture. So here in the middle, we have the evolution of mobile broadband as it is today and in the coming years, with the HetNet scenario, small and big cells together, lots of small cells, and perhaps coordination between the small and the big cells. Other use cases could be to cope with ultra-high traffic and ultra-high density, for instance, indoor. And in that scenario, we may even have more access points than we have users, which puts then definitely requires new functionality. We can have cars communicating, vehicular, with each other, but also communicating to the road, for industry applications, sensors, and maybe even sensors in a capillary network, which means that the sensors communicate in a local network and then backhaul over the wide area network. Multi-hop technologies, device-to-device communication, industry applications with robots communicating, but also then providing very high reliability and improved coverage. So there are a lot of different scenarios and use cases that we see. In terms of spectrum, we see that we have a shortage of spectrum, and it will force us to go higher and higher in frequency, but also to work more with technology such as spectrum sharing for the future. So coming then to the 5G wireless access. 5G for us is the evolution of the existing standards, but complemented by new techniques. So the way we define 5G, it is a set of radio access technologies that together jointly fulfill the requirements for 5G. So it's the evolution of what we have today, 2G, Wi-Fi, 3G, 4G, but then adding also new wireless technologies to specifically fulfill the new requirements we see coming from the network society. So 5G is not a replacement of 4G, it is an evolution of what we have today, but complementing with the new technologies that specifically are designed to meet the new requirements. Some components and aspects that we need to cater for with 5G. Definitely small cell technologies and ultra-dense networks. Power consumption and sustainability, we have to keep the power consumption down. Include advanced antenna technologies, secure resilience, security and privacy in the networks and in the access, management and easy management, and working with spectrum and spectrum sharing technologies to cater for the best spectrum situation. So we have already started 5G research, and last year we launched the METIS project, which is a joint large EU project with 29 partners. It's initiated and led by us, but it includes a lot of vendors, operators, and academia. And it will run until 2015. And the objective is to get alignment in the industry as well as with the regulatory bodies on 5G and the definition of 5G. So some of the objectives in the METIS project, the overall objective is of course to develop a concept for future mobile and wireless communication systems that supports the connected information society. And in a bit more detail, cope with 1,000 times higher volumes of mobile traffic, 10 to 100 times higher number of connected devices, 10 to 100 times higher end user data rates, 5 times lower latency, and 10 times longer battery life for low power devices. And on top of that, should not increase the cost and power consumption, so it has to be affordable and sustainable. So, to conclude, we see a tremendous growth in mobile broadband, and we foresee that that growth will continue. We see that the world is transforming into a network society. We see signs now, it has started already, but it will continue to grow and take off. But we need to evolve our networks and the connectivity to meet the requirements we see coming from the network society. And we have started research activities for 5G, and we launched the METIS project by the end of last year, the large EU project. Thank you.
Thank you, Sara. Comments or questions? William?
Thanks. You commented on the importance of connecting sensors as part of that vision. What wireless solution do you think you'll use to do that? Do we have to wait for 5G before we can connect those sensors?
No, I don't think we have to wait for 5G. It depends on the requirements that they pose on the wide area connectivity. A lot of those cases could be solved, I think, today already with 4G and the technologies we have, so we don't have to wait for 5G. Many cases, many use cases in the network society will be met by today's technologies, but for some cases we'll have to evolve the access.
Lauri?
Okay, thanks. I was very happy to see you mention privacy there also. Good. So, you mentioned that you had this in the first picture with the quadrangle, so you had networks and cloud separately. You did mention this network-enabled cloud, but still I would like to hear a little bit more that why do you picture networks and cloud separately and what's behind it?
Well, they're more and more merging together. As I try to say, at least, the technologies that we see will be needed for the network functionality, a lot of those will be cloud-based. So cloud technology is coming into our networks and will be the platform for a lot of the network functionality. So they could be merged into some kind of network-enabled cloud.
How about also small kind of distributed clouds inside the networks for accelerated storage and or content delivery and applications? Is that part of it also?
Absolutely. That's exactly what I'm talking about. Content acceleration has to do with the service awareness, caching, exactly that kind of functionality that you were talking about.
You had this nice picture of the sandwiches of the technologies. So how do you see the phase out or the retirement of one of the technologies?
That's a good question. I think a lot of the technologies that we have will be there for a long time. So most likely the phase out will be a long process. So we will live with that, and that 5G is the definition of the set of radio access technologies, including also the ones that were perhaps not born yesterday.
Gillian?
Yes, they are a very nice presentation. And in China, early in February, the government actually had led a launch of the IMT 2020 task force in China. And there, preliminary, we are also looking at the 3 paths towards 5G. One is what we call it revolutionary path. The second one is evolutionary. And the third one is actually Wi-Fi based evolution. I really like the way that you actually had the equation for 5G. Okay, so it's the evolution of existing standards, the whole family of existing ones, plus complementary new technologies. And
Yes.
you also posed some goals and targets and challenges for 5G. I just wonder if you have a feeling as to what set of the goals and challenges that you expected that the evolution of the existing standards could already address, and what are the ones that at this point you expected to have to be addressed by brand new complementary technologies?
That would then be some kind of guess or estimate, but I would say that most likely we can continue to evolve towards higher data rates and towards shorter latency. The question is how far we come. Do we need something extra to cater for ultra-low latency, extremely good coverage, really low power operation, super real-time, device-to-device, multi-hop? Depends on how far we evolve, but our feeling is that we will come, when it comes to higher data rates, most likely we will be able to go up a bit with the existing technologies, but perhaps not all the way. And in terms of latency, the same. So we will come away, but we may need to add other components to reach the really extreme cases.
How do you see the competence and the border between equipment supplier like Ericsson and operators? And a follow-up to that is, what do you see the core competence for the operator now in the 5G world, and what can you help them with, and what should they do themselves?
But first of all, I would like to say that METIS is a joint project with both vendors and operators as well as academia. So there we join our forces together, and I think that's has proven to be a good way to work previously for previous generations. So I think that is a good solution. What we can help the operators with is help them to realize and provide the functionality that is needed in the networks to meet the requirements from the network society. Because I said, yes, it will happen, but we need to evolve the networks to meet the requirements to make it happen. Did it answer your question? You look unhappy.
I mean, but you Ericsson, you run a number of networks yourself. So what do you see? What is your view on what is the core competence for an operator? What is the basis of an operator in the future?
That is a good question. Yes, we run a number of networks. We operate a number of networks for operators. It does not mean that we own the networks ourselves. One core competence for the operator, I guess, is understanding the end user business that they're trying to address.
May I ask a little bit nitpicking question here? You repeated several times anything that benefits from being connected will be connected. Does it mean anything that can afford to be connected will be connected? Or yeah.
Since
could that be a problem? I think that's a similar question.
It depends on how you connect them. For instance, if you have a capillary network, connectivity in the near area may not be so expensive, and then you can backhaul it over the wide area technology. So my estimate is that the threshold for affordness will not be that high, to be honest.
Okay.
But of course, I mean, to make it happen, the benefit has to be higher than the price. But I think that there are definitely such cases where the benefit is much, much higher than the cost.
I think we had a rather long debate yesterday whether that would end up in 50 billion devices or orders of magnitude lower. If you look at, or of course, this price tag may change over time. So
yeah, it may change over time, but I still think that anything that can make us use our time more efficiently and that can improve safety for humans, that has a really high price tag.
Yeah.
And I heard another story. I visited the conference and they told me about a little boy. His immune system was not developed, so he couldn't go to school. So he had a connected robot, so he could interact with his friends at school. So what is the price tag of that? For me, it's high.
Good point. Lauri had a...
on that. So I definitely believe we need to instrument the world much more for efficiency reasons and for the kind of priceable reasons, like you just mentioned the last example. But I think also that we should be careful not to kind of go ahead too fast, because I think that there's another revolution which we haven't discussed here too much, which is big data and analytics. And actually we can infer more and more about things without actually measuring them. So we don't really need to put the temperature gauge and things everywhere. We need to have a reasonable amount of that and aggregate that, and then we can infer a lot of things. So I think that we don't need all those many sensors. We need a lot of them, but we can do a lot kind of, let's say, lower cost and without polluting the environment with mechanical things. So just as a viewpoint.
I think you're absolutely right. My point was only that if we are now starting research and working on the 5G connectivity, we have to take height so that we can meet the requirements 2020 or 2025, because that is when we will need it.
Okay, then I think we are happy with all the questions and answers. So
Thank
thanks
you.
again, Sara.